Hi, this is Chris, and this is Cathode Bias, episode 8, down here in sunny Miami, Florida. Today, not too far from Little Havana, there is the big sort of Carnival Festival today, Cuban Carnival Festival. Why it's today and not 2 weeks ago, I don't know, but just walked up the street and listened to some Latin music and kind of walked back down here to record this, so had a couple of cervezas while I was up there, so I apologize if this is not as clear as it should be. But yeah, so it's a nice day down in Miami, and I'm glad to have you all along. Today we're going to be talking about the Fisher X101B integrated tube amplifier from early 60s. This is an amplifier I picked up from a friend of mine a few months ago who has a large stash of vintage hi-fi. Decided to pick this one out of his collection and try to resurrect it. And I've been working on this for, like I said, about a month. And here and there, not full time, obviously. Just when I get time to poke at it, I kind of do, and kind of want to give an update of what's going on with this, and kind of maybe some ideas about where we can head in the future, and just maybe give you some ideas if you're thinking about restoring an amplifier like this, so what to look for. Just again to set the stage here, I'm definitely intermediate when it comes to this. I'm not an expert. I don't do this full time. My day job is I work in software. I've done about 6 of these amplifiers. I've owned tube amps for about 20 years, but I've really sort of dug my heels in to really understand a little bit more about the restoration of these during COVID. And more than anything, I just want to share the information that I've learned over the last about couple, maybe year or so, actually, working on these amplifiers with other people. I think maybe I have a different perspective because I'm kind of new to this, and I think a lot of people have been working on these, have been working on them for a long time, and maybe just don't have the same perspective as somebody that's new to this hobby of restoration of tube amplifiers would have. So anyways, I kind of want to make this kind of brief, so if there's any details that you think are missing from this, feel free to reach out to me. Either leave a comment here, or you can find me on Instagram, Cathode Bias. You can send me a DM there, and we can go into more detail. But I just want to go quickly on the layout of the top of this amplifier, then talk about what I did on the bottom of the amplifier, and then maybe talk about some of the tools I have down here to work on these amplifiers. So again, this is the top of the chassis of the Fisher amplifier. These are about 30 watts per channel. It's in what they call a push-pull configuration with 4 tubes in the back, 4 output tubes. You get 2 per channel, basically. It's a stereo amplifier. Fairly high power for the time, and really kind of changed the market of hi-fi. And that's why I'm kind of interested in Fishers. Not that they're the absolute best amplifier of the time, but they represent a really good quality for the money. You got a lot of amplifier, a lot of features in one of these chassis for the money, which made them extremely popular in the 60s. And nowadays you can pick up a totally restored one of these for maybe $1,200 or $1,500, full retail price. If you're lucky, you can find them cheaper. I used to find them a lot cheaper, but the prices have gone up on this. This one I picked up for about $500, and it needed to be restored. That seems to be what I'm finding in the market right now. $500 to $600 could buy you a non-restored one of these, but expect to put a lot of labor into actually bringing one of these things back to life, which is what I'm doing right now. I think relative to a modern tube amplifier, that still represents a pretty good value. If you're to buy an amplifier that had both basically a 30 watt output section, a preamp section, and a phono section, this actually has inputs for a turntable as well, that you'd pay a lot more money than even you would a fully restored one of these. And a lot of ways the technology really hasn't changed that much from the 60s. There hasn't been big advancements in tube technology in the last 60 years. Most of it's been focused on solid state technology. Yeah, capacitors and stuff have improved. Maybe even you could say resistors. Some of the components have improved, but you can always add those into a system like this, and in my opinion, get the quality that's very similar to a modern tube amp out of one of these vintage components. And I guess I want to go to bat for the Fishers. I think if they're set up right and restored properly, they can sound very, very good and be pretty reliable. Maybe the one drawback of Fishers is their designs seem to always run the tubes at the very upper end of their sort of efficiency of their specs, really, and basically they wear out the tubes fairly quickly. So yeah, so that's kind of a overview of the Fisher, but kind of want to go through the tubes, and then we'll talk about some of the components on the top. So basically 12 AX7, 6 of them on the front of it, very common tube for preamp sections. This two over here, I believe, are the phase inverters that basically used to drive the output tubes by basically inverting the signal so it could be doubled up in the output section. I won't go into detail about what that does, but these are all signal tubes. The signal goes through all of these. Phase inverter, tone controls, preamp section. I believe that's the layout. I have to look at the exact schematic to be clear about that, but it's basically what it is. You have basically low power tubes that the signal goes through initially. That'll be the last here before going into the output section. The output tubes then basically amplify the signal even more. The signal does go through these tubes, so the sound of it can be affected by the quality of these tubes. And basically it goes to the output transformers and out to the speakers. These bigger tubes in the back, these are 7591s in this case, are almost always bad in these things if they've been used. If the unit's been used quite a bit, which this one obviously has quite a few hours on, these are almost always bad and you need to replace. On the other hand, these smaller tubes tend to be very high quality. A lot of them are Telefunken and or Amprex, which were made in Germany or UK, which the tubes in this were, and tend to be good still. And only reason I replaced these with some modern JJ tubes is just to save the other tubes for some other equipment I have that could really take advantage of sort of the higher quality tubes. I didn't want to basically use them in this amplifier. And also just want to see how the amplifier performed with a full new tube set. So the signal goes through basically all 6 of these and all 4 of these tubes in the back. The one exception is that the signal does not go through is this tube right here. It's called a rectifier tube. Not all Fisher tube amps, and actually most of them don't have it. A lot of amps from this time frame have what they call basically a selenium rectifier. It's an early solid state rectifier. The bad thing about the selenium rectifier is that they, when they go bad, it's actually toxic, and they are known to go bad. So I usually take them out of systems and replace them with diodes. In this case, you don't have the selenium rectifier. You get this tube that does the same job. And what that job is basically convert high voltage AC coming out of this power transformer and convert it into DC, basically DC with some exceptions, for use to drive the other tubes in the system. Basically, you need AC and DC power in the circuit to basically drive the entire circuit. I'm not going to go into details how the circuit works. That's kind of like a discussion for another day. But just put it this way. You're basically going from AC coming in this circuit into this power transformer and DC coming out of here to this mostly, which I'll talk about in just a second. So these black things, like I kind of mentioned, are transformers. This one takes power from the wall and it basically increases the voltage on it. And these are basically transformers used prior to going out to the speakers. Turns out this one has been overworked because of other bad components in the system. It's probably serviceable, but it has a bad hum and is heating up quite a bit. You can get these, basically I've heard you can get these rewound. I've never tried it before, but I found a replacement. It wasn't cheap, but I found one in Germany. I'm going to have a new transformer set out for this unit. I'm going to try to get it sounding as good as possible. And this transformer just isn't performing as well as I think it should be, so I'm going to have this transformer replaced. I think what's probably of most interest to people just starting out are these two cans right here. What these are basically multi-section capacitor cans. They have, each one of them has basically, I think this one's got 2 capacitors in it, and I think this one might have 1. Usually these have basically from 1 to 3 capacitors in them. This type of capacitor, for all practical purposes, is archaic. They don't use these anymore in modern systems. They use basically axial capacitors. Let me have one here, kind of more that look like this, basically. So the problem is it's kind of hard to get replacements for these. So there's a whole bunch, and I talk about it in our previous video, ways to go about replacing these capacitors. And it's important because these almost are always bad in the system because they're electrolytics capacitors and they dry out and they go bad, and basically the system will not function properly at all with these. Almost every one of these amps I've worked on, you need to replace these capacitors in the power supply. And what they do is they take the high voltage current that's coming out of the transformer through the rectifier. After it comes out of the rectifier, it's not a completely flat DC with no sort of I don't know what you say, no curve, or doesn't attenuate up or down. It still has what they call ripple in it, and so basically the current goes through these filters, and basically when it comes out of these filters, you have basically clean DC. So without these filter caps, basically you'll have noise going in the rest of the system that basically is from the AC system. It's still basically some AC leaking through, which it should be 100% DC after it comes out of the filter caps. Now, one of these caps actually, it has not just a used filter cap, is also used in the bias circuit. So these might have multiple purposes, but in general, you can think of these as taking sort of half converted AC from the rectifier and converting it 100% into DC. What it really does, it doesn't really matter that much. What matters is you have to replace these from a practical standpoint. And so there's multiple ways to go about it. Sometimes if you're lucky, you can get pre-built cans. Here's one of them from a company called CE Manufacturing. And you can just drop these right here. Like for the Dynacos, these cans fit right into the Dynacos and they drop right in, and you replace these cans with sort of like these CE Manufacturing cans. So that's one way to do it. Another way to do it is the original cans just look kind of more like this, and you can basically cut the bottom out and replace the capacitors in there with capacitors like this, and they call it restuffing. You can basically put new capacitors in there and then put them back in here. I'm going to say I don't recommend that, but primarily because it makes a big mess, and like, who knows, there's a bunch of, there's like tar type stuff in these capacitors, especially the old ones. I don't know about the new ones, but the old ones, who knows what that stuff is. It might be toxic. It's probably, the safety standards that you have today weren't in place 60 years ago. I really don't like messing around with that goop that's in these things. So I think the easiest and most foolproof way to replace these things, and not the cheapest, it's definitely probably the most expensive option, is to go to Hayseed Hamfest, and I'll put a link in the description of the video, and buy these things basically pre-made specifically for this amplifier. Now, on another amplifier, I made the mistake of buying a kit, a quote-unquote, that was supposed to be a complete kit, and it didn't include these cap cans. Basically, it included a handful of these things, these axial capacitors, and then that gives you another option. So you can basically hack them in under the chassis. But if this is your first restoration, like, I would not recommend going that route, because there's a lot of wiring that has to be done. You have to basically drill into the chassis to put in terminal posts to mount these things to. It basically makes the project way, way more complicated, and the end result, I believe, isn't as clean as just using when he's using these Hayseed Hamfest drop-in replacements for the cap cans. There is one other thing I haven't tried yet, but somebody recommended to me, was the M2 has like there's M2, something called M2 Hi-Fi, I think it is. I'll put a link in here too on Instagram, that makes like something that basically like a circuit board that's circular. They can basically replace these with, and then put in axial capacitors in there as well. So that's another option. I haven't tried that option, so I'm not going to say if it works well or doesn't work well. But what I recommend, again, if you're starting out, just pay the extra money and get these Hayseed Hamfest ones. If you're looking to save money, maybe this is the wrong hobby for you, but you can try restuffing the cans, or maybe try that M2 solution. But from just a practical standpoint, this is a much more easy way to go. I'm kind of joking about saving money. This is not once you start going into this hobby, like, just the tube will rate alone, and this is probably about $150. So it's not it's definitely had to do it for the love and not for the cost savings, basically. A couple other things to mention on this chassis. One, it has a plug for remote control. It's kind of cool. You basically control the volume with this when you take it out. But the actual remote control unit is fairly rare, although I did see one on Instagram recently. I've never seen one in real life. So that plug just basically plugs up that option. This is a pretty important knob. Basically, it's a potentiometer, potentiometer, which basically allows you to set the bias on the tubes, which is basically the voltage going in the tubes. I'll show you how you test it. But you basically have to set a probe underneath the chassis, and then turn this knob to get the voltage to exactly 44 volts across all these tubes. One thing I should mention: these tubes have to be matched because there's only one of these in like the Marantz 8B, and Marantz 8 has 4 of these. One of these for each tube. Since there's only one of these, you have to make sure these are all matched and the voltage is the same across all of these, and the bias. There's also these 2 potentiometers over here, which they have to do with the phase inverter, and basically reducing the harmonic distortion. To be honest, like, I don't have the right tools to actually set these. I guess we set them to the neutral position and test the voltages, and it looked all right. But I don't honestly have the right tools to test this with. I'm trying to understand like how I can do this as kind of a home enthusiast. Actually set these to the right position, basically. But they are not, from my understanding, not as important as basically setting the bias properly on the output tubes, which is what this does. And fortunately, it does have one here because not all Fishers do. And then you have to get the bias right. You have to like change out resistors and stuff, which makes it kind of a pain in the ass. That goes back to what the name of this website is, the cathode bias. But you basically have a resistor in the bias circuit that basically drops the voltage down, so you can measure it across. I won't go into what the details of what that means today. Fortunately, you don't have to do that with this because it does have this potentiometer in here right now. So that's kind of it from the top of it. Again, like, if you take one thing away from this video, you have to replace these 2 things almost always. And some of these have 3, some have 4. The Fisher 800B I have has 4 of these things. So like, these almost always all have to be replaced. And yeah, so that's kind of the look at the top of the X101B, and we'll be right back to talk about the bottom of it. Okay, so now we're looking at the bottom side of the X101B Fisher. Yeah, just word of warning, like, shit's about to get real here. Now we're talking about a live circuit. It's not plugged in right now, but potentially if you were working on one of these amplifiers and you were plugging in and testing it, this circuit, it has 400 volts DC plus all over the place, and coming out of the transformer, I think, is over 700 volts AC. So you just have to be really careful when working on these. I'm not going to go into like the specifics of how to probe one of these amplifiers today, but maybe I'll have a follow-up video where I can give more specific advice on how to test voltages on one of these. Today, we're just going to look at it completely unplugged, everything discharged, and in a safe, sort of steady state here. Again, maybe what I want to repeat again is, like, from the earlier videos, the things you really want to replace in these systems. One thing is, you notice is very tight wiring in these Fisher receivers. This one's particularly tight in this area in the preamp section, with a lot of coupling capacitors and resistors, which is maybe a little bit more why these are more complicated to work on than, say, like a Macintosh MC240. You get a lot for your money in this area, but you also get a lot more complexity in a small area. That's kind of the trade-off you get with these. Again, these can be built to sound very good, but you have a lot of complexity under the chassis in one of these. And it takes a little while to understand what it is you're looking at. But maybe the important things to look at are these 2. These are the multi-sectional cans I talked about in the previous section, only from underneath. They've been rewired in. Again, it's fairly simple to do. What you need to do is basically remove the old cans. Whoever did the work on this before had a ton of solder on here. I need to go back with a wick and remove some of this. I don't know what they were thinking, but somebody else had removed these at one other point and just soldered the hell out of them, quite frankly. So it's still kind of a mess of solder on here that I'm going to go back and clean up. But I did get it wired in. Basically, this is your C1 filter cap, which I talked about filter caps before, basically converting the ripple current into DC. This is probably one of the most important capacitors in the system, and it was bad. You can see all the leads coming into here. More capacitors in the power supply. This one I think is a bias capacitor, and this is another power supply capacitor. But basically what you need to do from a pragmatic standpoint is cut out the old capacitors, put these new cans in, make sure they're in the right direction. They have to be oriented properly. That's really critical. They just can't willy-nilly throw them in. They have to be oriented properly, I usually take a picture of the old one and just wire them in exactly how they were wired in before. I'm not going to go into like how to solder or anything today. I'm assuming you can do that. But if you can basically just, like this big ass joint here, like you just have to make sure it's like this is the right lead that goes to all these other, the right tab out of the capacitor can that leads to all these other joints. But it's like, I didn't change anything in the circuit at all. I just dropped in the new capacitor and wired everything up exactly how it was. The nice thing is the schematics on the Fishers are pretty descriptive. They also describe the values of every component in here, so you can orient yourself fairly easily on the Fishers. I mean, I love Marantz, and I think Marantz are definitely more sophisticated unit, but damn, their schematics are hard to read, I gotta be honest. The nice thing about working on Fishers, if there's a drawback, is how complicated this wiring is. If there's an advantage, it's how good the Fisher schematics are. They're really easier to read, especially for this X101B, than some of the other schematics. But I didn't change anything with the wiring. I kept it exactly how it is. It's with two exceptions. So one of the exceptions, this is the rectifier right here, and I added in these little diodes right here. These basically do the job of the rectifier right here, and this is kind of a hack that I found from the Dynaco forums. The Dynacos also use tube rectification. Basically, I'm taking all the load off the tubes by using these diodes. They do the same job, and I wired them in across the unused pin on the rectifier, and then basically wired them into the hot pin. This just basically takes load off the rectifier. More than anything, the rectifier is there for aesthetics. It does there is a circuit that does create a cross tier, but more than anything, the rectifier is there is more for aesthetics. Like I could drop in a totally solid state rectifier at the top of it, but I just don't like the way they look. And then basically the rectifier was there originally, so even though we have solid state rectification using these diodes, the original rectifier tube is still in place, and hopefully it will last a long time because there's not a lot of load being put on it. This is where the ripple current comes out of the rectifier that I talked about before, and it comes into these main voltage dropping resistors. These were really heating up because of these capacitor cans being bad, and actually it melted out some of the wiring here, and I actually went back and put in I put in some heat shrink in here and replaced both these resistors because they just have been overstressed. They probably would have been okay to keep running with, but these ohmite resistors are really nice. I just like the way they look aesthetically, and the original circuit had two resistors in parallel, again to try to get the power up enough to drop enough power here, like enough voltage over, with a lot of high voltage over short, with a high voltage drop, it requires a lot of power. They have two in parallel. You could do it with one modern resistor, but I just decided to keep the circuit exactly the same as it is in schematic in case somebody else comes in here, they know what's going on. It's pretty easy to see that these two resistors were just replaced with exactly the same thing. So I had those two resistors replaced. These two cap cans replaced. So this other thing I did was there's one other electrical cap in the power supply. I think this is the part of the bias supply. It's way over here. I didn't even bother measuring whether it was as good or not. It's electrical cap. It's eventually going to go bad. The goal is to keep the amplifier stable for a long time. I just took it out and replaced it. I think it was originally a 20 microfarad plus or minus 10% capacitor. I put in a 22 because that's what I had available. It's within 10%. I think it's fine. I have a 20 now, but I tested all the voltages across here and everything looks fine. So I think the fact that it's within 20% of capacitance or within 10% of capacitance, I think is not an issue. I think I'm just going to leave this in here right now. So I did replace this. It's fairly easy. It takes about a 10-minute job, quite frankly, to replace that. The other thing I did here was replace these coupling capacitors in the tone section. The reason I replaced these and not all the other coupling capacitors was they were mismatched. Somebody had already gone in here and replaced one of these and left one of the original ones. Even though these are they don't look symmetrical. If you look at the schematic, these do the same job just for different channels, right? So I actually used the audio quality I think there's Sozo capacitors in here. Not super cheap, but not super expensive capacitors. One thing is, again, you have to be concerned about the size, right? There's not a lot of room in here. So these are fairly reasonably sized capacitors to get that job done. Again, the reason I replaced these is they'd already been replaced once and were mismatched. The only other thing I've done in here, and it's looking at it now, is surprising considering how long I've been working on this. Is so I replaced these two caps, replaced this, we put these diodes in here, like I mentioned, replaced these two cap cans, and the last thing I did just today was I drilled a hole in the chassis, put this what do you call these things? It's basically a standoff in here, and to mount a terminal strip to basically mount this thermoresistor. Basically a C80 thermoresistor. This one's made by Ameritherm in Carson City, Nevada. I like these because they're U.S. made. They're not imports. These are typically used in like I don't know, like AC units or something, but they fit right in here perfectly. And what this does is, this is kind of an add-on to the circuit, kind of like these diodes, is that I noticed, especially when I was running with only diodes, that there would be a huge voltage shock to the system, and the voltages were like very high to start up with, and then it would settle down to something more operating voltages. So I didn't want to get that shock out of the system. Basically, what happens is you put these in here until these heat up very slowly, until they heat up to full operational temperature. They don't allow the full current and full voltage to come through the system. It does take a little bit longer for the system to come up to actually to play, and you can hear music through it. But I think it's worth it just to keep the jolt out of the system. Like, I don't do this with every system, but the MC240 comes with one of these stock, and I actually put another one of these in another Fisher I worked on. But this one in particular, probably because of the transformers, was definitely having a lot of high voltages in here right at startup. So I did hack this in today, and basically what I did was I put a lead wire in from the fuse to here, just add one wire, and then just the lead from the transformer disconnected from the fuse and put it here. That's about. And then the other thing is I drilled a hole in here to mount the I can't always remember these, like I can't remember these, I guess call them standoffs, but just drilled an 1/8 hole in there and mounted it directly to the chassis. So there's a little bit of a screw on the top of it that you can see, but other than that, it's a pretty clean job, and like I do recommend putting these into Fishers. So I mean, that's pretty much all I did to really get the system up and running. Like, I would say in 80% of these, that's all you really have to do is, like, okay, power supply caps, boom, boom, boom here. All the electrolytes are out of here. Okay, these were kind of optional, but looked like they were overheating, so replace that. Put a thermoresistor in here, place a couple weird coupling caps, and it's up and running again. These coupling caps here, like, these are going between different sections of the amplifier, and these affect the tone of the amplifier. And a lot of people say that these are still good. I believe these are German-made coupling caps. You can replace these or you keep the same. I think unless these don't measure out right, I'm just going to leave them. I'll be honest, this amplifier is running pretty good and sounding pretty good. It's going to just do some more testing on it, and I'm not sure if I'm going to do any mucking around with these. And there's a whole bunch of little smaller capacitors in here. These almost never go bad. You can replace these if you want, but that's kind of like totally optional. I think the really the main ones that get replaced in these things, like, again, any electrolytics, boom, boom, boom. Then, anything that looks like, well, just hacked in there, these here. And then you can replace these coupling caps as kind of optional. Then the thermoresistor, and that's it. That's really all you really need to do to get one of these things up and running. I mean, I can't guarantee that there's not more deeper problems, like something might be soldered incorrectly or something, or there might be a bad switch or something in here. But as far as the main, like, circuit, those are almost all the things that go wrong in these things. And, it's very rare for, like, resistors to go out of spec. I'm going to go back and check all the resistors, make sure in spec. Usually if they're out of spec or something's wrong, you'll hear a hissing. Not so much a crackling, but a hissing noise. And, yeah, that's something you have to check. Oh, maybe one other thing I'll talk about quickly is just I remember I talked about the bias voltage. All you have to do is put a probe. I think this is pin 5. Don't quote me on that, but you put a probe. I think this is it actually. Yeah, on pin 5, and then put it on your multimeter, and then connect your multimeter to ground. Turn that knob underneath and make sure this is reading at 44 volts in a DC exactly, and that's all you have to do to set the bias on this. So I'm not going to probe around here today. I think I'll make another video how to do that. I just want to show, like, it's really not a whole lot to do on one of these to get them up and running. And really, if you buy these KC Hamset Fest things, it's just a matter of disconnecting the old ones and reconnecting the new ones and doing a little bit of soldering. And that's, that's really about it. And I'll show you, next thing is I'll just show you some of my tools I use to do this. And we'll go on from there. Talk to you soon. Okay, so the last thing I want to talk about today is just some of the basic tools that you need to do a restoration like this. It doesn't take a lot of tools, but maybe there's a couple of specialty items that you need to kind of do a vintage hi-fi restoration. Probably one of the most unusual is this VARIAC. This is a vintage one. I have a couple of these. Basically what it is, you just plug in whatever you're working on, the piece you're working on here, and then you can control the voltage going into the system here. So like when I bought a Fisher 800 yesterday, and so before I do anything with it, I'll just bring it up at low voltage and see see what's going on with the system before I bring it up to full voltage. So anytime I make a change in any components, before I basically bring it up to full voltage, I'll bring it up slowly on the VARIAC and kind of test the voltage in the system to see if they all still make sense relative to each other. You're not going to be able to measure the full voltage in the whole system, but you'll be able to see, like, hey, am I getting voltage out of the transformer? Am I getting voltage out of the rectifier? Am I getting voltage out of the C1 kit? You can basically see at a lower voltage if the system is basically functioning properly without bringing it up to full operating voltage, which, like, again, could be hundreds of volts, AC or DC. It's much easier to test things out at low voltage. So these are almost an absolute requirement. You can buy VARIACs on Amazon for not a lot of money. I don't think the quality of them is that great. Basically, you can buy these used on eBay for the same price. I would just look for one of these vintage ones on eBay. And then if you're concerned about how reliable it is, just put your multimeter in here and test the voltages out and see how close it is to this. This one actually measures a little bit high, but I know that, and I can basically account for that when I'm working on it. It doesn't really matter that much as long as it's close. Basically, you want to constrain the voltages, which this one does fine at. So that's the VARIAC. Got some wire cutters here. These are, you kind of need some kind of more very narrow or very kind of precise wire cutters. These are actually, I think, Swiss made or something, but you can buy these on Amazon. There's millions of different ones of these. Decent solder. I think this is like Kester solder. Basically, it's a high quality solder. I tried some cheaper solders, but the truth of the matter is they did not flow well. And I just basically put my solder on a chopstick like this. It's a little easier to manipulate when I'm working with it. So chopsticks, again, also come in handy, like I showed in my video, just for pointing at things. They're non-conductive, so if you want to make sure you don't want to get a shock, I would recommend just pick up a couple chopsticks. So I have a couple just electrician Klein tool screwdrivers, Phillips and regular head. Nothing too fancy. Any screwdriver will do the trick there. Neednose pliers, pretty critical for doing any kind of removing components out of the system. You want to have a pair of those around just to make sure. Again, those are pretty common, but if you don't have one, you're going to need that. Let's see what I do is look at my multimeter. So what's kind of interesting is that my brother's actually an electrical engineer. He does this stuff for a living, and I was actually talking to him about testing tools. He says, don't go for the fluke. Don't spend a fortune on testing tools. All you need is kind of like a decent, kind of like true RMS is called, the multimeter. And you can buy like this multimeter. This one does everything I needed to do. It costs like $30 or $40 at Amazon. I actually have two of these. Another one of these in Tahoe, so totally recommend these. I've had no problems with that at all. Yeah, so another thing I have here is maybe you can more specific to this task is basically a discharge capacitor discharger. It's basically a resistor on a stick. You put this thing on the chassis and ground, and then hit the resistor, hit the capacitor lead, and make sure it's discharged. Maybe the one nice thing about this is it has a light on it, so if there's any charge on it, you see that the light comes on. Other than that, there's videos online. You can make these just by putting a resistor on a stick. These cost like $5, so I figured I'd just go with this. Kind of nice to have the light, so I bought that on Amazon. Okay, maybe it's a little more interesting. Here is this is the soldering iron I'm using right now. This is interesting in that it uses the Hakko T15 tips, which I'll show you in just a second what they look like. But basically, the tip has got all the intelligence in it, and basically all the heating coil, everything, the heater element, and also the kind of the temperature gauge. Everything is basically built into the tip on this, and then you can basically buy these cheap sort of Chinese soldering irons to go with them. And the nice thing about this one costs like $70. Just bought this just for this project. I'm gonna obviously use it in some other projects, but I want to try it out. And like the equivalent Hakko costs like $250. And it uses like a tip. Let's see if we can find one. Here's an example of the tip it uses. Again, like a typical soldering iron has like a really short tip, and they're just all they do is conduct heat. That's all they do. But this one is actually has the heating element in it, and then also the sensor to tell like what the temperature currently is, kind of a thermometer basically, all built into the tip. And you can use the Hakko tips on these things, which I did. So it comes with its own tips, or you can use Hakko, either one. And these seem to work really good, and I have no complaints. Other thing I got here is kind of a light with a magnifying glass. I don't use the magnifying glass too often, but occasionally I do. But I definitely use the light. I also have some like alligator clips. Those are definitely handy for holding on to small components. Not a requirement, but nice to have. One thing I don't have here that I would like to have is some more soldering wicks. I'm going to buy some just to desolder some of the joints. Like you saw a lot of solder on that X101B. Need to get that out of there. The other thing is just my scope. I have a scope back in Tahoe. It's a really nice hand tech, but it's a fairly inexpensive consumer grade. Has a built-in signal generator. Those are really nice for working like preamp sections and stuff, to make sure everything, the balance is in correctly, and the tone controls are working properly, etc., etc. And you can get away without it. You can do a restoration just by checking voltages with a multimeter. But scopes are pretty nice. I really want to get one down here and bring one down here just for doing more advanced sort of preamp work and some other work. But that's kind of basically my basic toolkit. The main other thing is the silicon mats. I got a couple of these. Just put these on your desk, and you're kind of ready to rock and roll. I mean, maybe for $150, maybe $200. Let's call it with the VARIAC. The VARIAC and basically the soldering station would be your biggest expenses, but probably about $200 you can get off the ground and with the tools you need to kind of do vintage restoration. So, yeah. So thanks everyone. Hopefully you learned something today, and I will go into a little more detail about how to check voltages in the next video. But yeah, that's kind of where I'm at with the X101B, and I'll have some other projects coming up, and we'll talk about those soon.